Man, we could have met up. I was actually there. Like
No,
in
I
person.
didn't actually go to
Um,
SIGGRAPH. I watched it remotely.
oh,
Yeah.
oh, you watch it remotely. Well, you
Okay.
saw what was interesting to me about that is they have, they're looking at $50 trillion of ecosystem in heavy industry that they're looking for.
No, I know.
Sorry, this is my child's like
That's okay.
scooter coming.
Fine.
I
We've
said
got
at 12,
children
my
running
child's
around here
scooter's going to
too.
walk in.
Yeah, yeah, I
But
imagine.
but when you're thinking about like 14 trillion of that is the ecosystem of AEC, right? Like really just building buildings. So like I think, and there's a lot of overlap in that 50 trillion of like some of the big owners and like some of the big makers and manufacturing. A lot of it centers around some of the target audience that you're looking at. But
Yeah,
it's
we've
just
lost
interesting.
your video.
But it's fine.
You
It's still
have?
recording on her end. It's all
Oh,
good.
it's recording on
Yeah.
her end. Okay. Well, then I'm not going to
Yeah,
worry
that's
about
the
it.
beauty of Riverside.
No, we can't
Right.
see you, but we just believe you're there. It's okay.
That's so weird. That's the video. That's the beauty of Riverside, as they say, right? Like it's always recording me. I see myself fine on my and see you guys, but yeah.
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 No.
So, are they going to be okay?
They'll be fine.
Okay. So, no. So what was interesting in the keynote that I watched about SIGGRAPH was that people talk about digital twins. The whole evolution of the way the GPU evolved through the RTX line of GPUs, where they actually were doing AI inside of the GPU in order to
Right.
optimize ray tracing, right? To move away from rasterization to ray tracing. And now the
Right.
latest generation is literally 100 times more effective at being able to.
That was crazy, right?
It is crazy. But when you and I think of a GPU as a board we put in a computer, or maybe Chris does
Yeah,
as
I
a
use
gamer.
it to play games. Yeah,
Right.
That's
But
for my
but
Apex
he goes,
sessions. Yeah.
this 2 foot by 2 foot by 2 foot cube is a GPU. Like that's a GPU from NVIDIA. And they all composite to be a wall, a data center wall,
Sure.
which is a GPU.
Right.
And no, but
because it's just like distributed compute against like a humongous
neural executing
Yeah.
machine learning system. But
they're all sharing the same storage.
well,
or
they
to an
can,
extent.
right, and their system has it. But what I didn't appreciate until that talk, which I really liked, was they use the term digital twin. We actually do as well at Cargo Sense. So they use the word digital twin to say we are going to create an accurate replica of this thing in the real world inside of our system, including physics.
Sure.
So that we can train AIs in that virtual environment.
So think about what you just said, though, which I think this is the interesting part. In movies, which is what OpenUSD was made for originally, right? You
Pixar,
only
right.
need high quality visualization and renderings.
Right.
To actually build a building, you need real content down to the fastener level detail, right?
Correct.
Like you can visualize all those things and you can have architects like sell projects based on that visualization. But you in order to build off that digital twin and to function off that digital twin, you need things like Smart Factory that they're doing and Workbench AI. You need people to actually digitize the content down to the fastener level detail so
Correct.
it can be tracked and visualized and actually reused as that data. That data needs to be reused and be able to be called upon whenever you want to use that for not just visualization, but beyond that into actually building things. And I think that's what's really interesting about it.
But what he was talking about is especially robotic systems, the ability, if you can simulate that real world digitally, you could train AI in the virtual environment and then transfer that trained model, which is very computationally expensive and done in an artificial environment, into robots, which are in the real world. You can combine.
Right. And they showed that with cars, right? Like, because cars have very finite pieces and parts, right? Like they actually have things they have productized those components to build cars.
Right.
We don't have, the AEC space hasn't found I don't want to say it hasn't found a reason to do it, but from a business perspective, it needs this kind of paradigm shift where that using that and defining those would make it useful, right? Like
Agreed.
if you don't have OpenUSD and you don't have the Omniverse, it's not useful to actually get down to that fastener level detail. Or if you did get to that fastener level detail, it was very for one single, use case that you used it for this type of skid in this environment, but it doesn't mean someone's going to use that skid again to design with it. So it's, the sort of the part of my thought leadership around manufacturing informed design is like, we have to stop doing assumption-based design for construction. We need to start understanding, level of, manufacturing quality detail. Even if we're finding it out at the end of these projects right now, we've got to be able to capture that and reuse it and have it be able to be consumed in a universal language by not just, people like Autodesk, but people like Bentley and people like, Hexagon and whomever, ArchiCAD, whoever wants to use it should be able to go on to a universal platform and actually be able to like store data there and consume data, compute data for these reasons, right?
And use it for different purposes. So he used an example of designing an extension to a manufacturing plant for storage. It was towards the end of the SIGGRAPH talk, but and it like, okay, we're going to build up racks, and it was just like this stuff just like formed inside of this space, magically. Like this is all just, racks show up. Like, rack layout is not just like, we're just going to show up. It takes time to lay it out. The way forklifts are going to flow through a space and everything else like that. How much open floor space do you need? Are you bringing in ULDs you have to tear down and, turn into pallets? Or how do you palletize things? Where are we going to, shrink wrap our pallets? There's a lot of stuff that happens inside of a warehouse. But it was fine for the sake of what they were showing. We can build this up. But if you, we've been in so many warehouses. These are storage warehouses, right? Because we're dealing a lot in freight logistics and stuff. That if those warehouses had a model of sufficient detail, you talk about down to the fastener level and things like that, right? The level of detail necessary to do what you want to do, if you get it at the finer grain, there's a lot of things you can do. Maintenance, all kinds of things you could optimize in that. But at a coarser grain, when we think of digital twins, we're much more coarse grained. We're really trying to reflect something happening in the real world, as opposed to we want to build a model of that real world thing and then simulate what we do inside that model so that we can optimize the real world thing. What we're doing is we're measuring what's happening in the real world. We're pulling everything we know about that thing into one place, so that we can automate on top of it and ensure that everything is going according to plan, especially in supply chains, right? Making sure that things are progressing as they're supposed to, that they're moving to the right locations, that they're being stored in the right way, all those kinds of things that are necessary in order to make every shipment work as you want it to. That's the kind of automation that we're doing on top of our digital twin. And it is a digital twin, not at the fine grain level of what NVIDIA was talking about, or OpenUXD, the ability of of building those finer grain, all the way down to construction, right? As you talked about, and architecture, and because it's all going to be based on that. It's all going to be based on those things they use to build the building, if they're existing buildings, and build those up. A fine-grained digital representation of your building that will be built, getting that turned into a digital twin as early in the process as possible, pays for itself, not just through the building process, but through the ongoing use, maintenance, and operational cycle of that thing.
Well, it goes beyond that. So I think most are using coarse detail today because that's all you have. If you I think that needs to be said. Like if you really could get things like sustainability information, supply chain availability information, performance data based on past performance of those component parts, you would want that in the model instead of the coarse grain detail that you have now. I think most would say the same. It's almost like I just don't even know if they think it's possible. So like when you say, and it's funny, I also think that people are speaking about it as if just exactly how you spoke about it. Like if you had a digital representation of that building you wanted to build early enough, it would pay for many things. It would stop a lot of rework. But I don't think people really, you almost have to like back up and say, if I actually designed that building based on what I knew about those components in advance, and that some other algorithm test fit those components for me based on the parameters I set for it, before you even got the design, it pays for itself. So
agreed.
as an example, think about like the data center guys that we know out there in the world, right? I used to build data centers. If I could take a piece of land in advance and understand layers of digital twin, not just asset twin, which most talk about, but let's say I wanted to understand fiber twins and weather twins. And I wanted to understand like undersea capacity, like in that fiber map in the twin. And I also want to understand, all of these water twins, because I need to like understand that, and energy analysis twins. If I could really understand all that in a layer, I could say, okay, do I want to buy this piece of property, knowing that the components are going to give me, first use case of X and like end of life would be Y as a cost. And he went through some of that in the data center side. Imagine even that, filling it with those racks that he stood in front of. So now not only is it the racks that are getting that efficiency, which again, he showed sort of like first cost. He didn't show over time that energy savings over the next 25 years would have been like an even more mind-blowing number. But imagine you were able to say, I want to look at this piece of property versus that piece of property based on these layers of twins and the parameters that I'm setting as an owner. Like sustainability, think about embodied carbon. Sustainability is more important to me, embodied carbon. Think about like scope 3 carbon, the stuff that you are usually like touching. Like you would love to be able to understand the data of scope 3, and especially when you're thinking about supply chain management. But it's, again, we almost don't think that that's possible. And I think and I'm not saying it's possible like right away, but I think you have to get on these platforms. You have to start understanding what capturing this data will actually do, so that it goes in a cycle, so you can keep reusing it and keep improving it. And that data needs to live somewhere. And I think that's the beauty of like, the Omniverse and some of the tools that can be built up there. And I thought that was just, again, like what they're trying to do over there and others is so unbelievable and so inspiring. It's just missing from the conversation right now. It's like
it is.
Right?
And you talk to the possibility. I think that we underestimate the way in which simulation of the world, with in gaming and various things like that, ties into the real world, because we think of it as two different things. It's not. Yes. And NVIDIA clearly is saying it's not, right? And the extent of what they're trying to do is clearly saying it's not. No, when we say we measure the real world, think about this in a warehouse today, trying to be able to know the precise 3-dimensional location of a thing moving through a warehouse through measurement is hard. Right. It's largely an unsolved problem. There are technologies that can be applied, like ultra wideband. It's just inefficient, right? But the ability of knowing the precise 3-dimensional location of something moving through a space like a warehouse allows you to do operational optimizations. But if you're doing that, you have to have the model of that warehouse in a precise 3-dimensional way. So what I meant by, because you're so knowledgeable and would love to get deeper into it on the design side, right? Like Autodesk and everything like that. And the build side of these things, like you talked about data centers. And then there's the operational side. There's that longer word, like what if we need to expand? How would we do that? When we talk about data center construction, we oversee the shipments coming into data centers for a big owner, Google, of their data centers and all over the world. Right. And when those shipments are coming in, you're talking about thousands of truckloads, heavy haul truckloads of things being brought into that has to be factored. You have to escort every heavy haul truck going across state lines and in state with an escort. Usually like state police and stuff like that escort those because they're very large, heavy loads. And all of that has to be thought
different
through.
for every state, by the way. Different for every state, by the way. The way the escort system works based on your capacity is different for every single state. Yeah. So what you're saying is true exponentially by each state, right? So, like just so you know.
But you are right in that all of that has to be factored. When you're choosing a location, what is the flow going to look like of stuff just coming to build this thing? much less,
Absolutely.
ongoing maintenance.
Yep.
What is the environmental impact of that? What are environmental concerns in the area?
Yes.
Right. And the features of that area to be able to handle certain things that others can't. And it's not just about power. Water is a bigger sustainability challenge that a lot of people have talked about now than
Yep.
more so than even power.
Absolutely.
Yeah. So,
And
but
I want to
yeah.
get Amy's reaction to all this, but before we do, I want to actually start the show properly and give her an actual
Wait,
introduction.
you better use some of that. You better use some of that on the show. By the way, that was some of the best things we could talk about.
We kind of ease into it, right? So let me get the title cards or space for it anyway, and then we'll
all right.
give you a quick intro, right?
This is our cool intro music. That Chris picked for us.
Yeah, we get a little group on before we get going for real.
So
yeah. All right. Our guest on the crosstalk today is a globally recognized expert in the field of industrialized construction. She has experience in both the public and private sectors, driving innovation in construction at the intersection of process and technology, most recently at Autodesk. Amy Marks is the queen of prefab, and she joins us here on the crosstalk today. Welcome, Amy.
Thank you for having me. I appreciate it.
I chopped that intro together real quick before we sat down here, so I hope I did you justice.
Yeah, no worries. All good.
Anyway, yeah, it's great to have you on, and I've been looking forward to this conversation for a long time. Clearly, yeah. Rich has also, because he's ready to go. He's like,
I didn't know that this was a conversation we were going to be having, honestly. Yeah. But no, it was just fortuitous because I literally just watched that SIGGRAPH talk yesterday. What's great is I have a 14-year-old son. We watched the entire keynote with my son. The entire time he's like, "Can I get that? Can I get that? Can I get that?" I'm like, "No, you're not getting a data center wall of GPUs, son, yet." Yeah. But
I mean, maybe.
Yeah,
but
maybe
yeah.
he could make use of it as part of their Omniverse tools. No, I just real quickly, CargoSense involves a lot of itself in the the automation of simplifying supply chains. And really it's around how can we use things like our platform or others to make sure that things like shipments, different assets are moving through supply chains in the way that we planned versus executed. And in the real world of execution of logistics, the way I actually liken it to this, and it's kind of funny coming from Autodesk, my uncle, back when I was 18, I first moved here to the DC area. He was a construction scheduler. That's what he did, and he'd been doing it by hand forever. And but I learned critical path method and PERT and everything from him. And he was showing me these plans, and he was like sketching all out how he would basically build these different. He was in Jamaica, so building out things in Jamaica, but he had the as planned as built. Right, every shipment in logistics is that. So you think of buildings. So we have a building, and you have your as planned and then as built, and they vary, they change. Architects make mistakes, things come up. You have to redesign things on the fly during construction, right? You would hope that you would not have to, but just the reality is you have as planned, as built. In logistics, every shipment has a plan, every single one. And then you have the as executed, and that as executed will vary from that plan. And when those deviations happen, they have different impacts on supply chains, and they can be significant. Outcome. Imagine if it's one thing to say, okay, well, I'm got this shipment that's going to go through the Suez Canal, and it's going to go through, and okay, that's easy. It's just going to go through that, and then all of a sudden, something turns sideways in the canal and blocks it, and all the ships on the other side of it from being able to go through. It was unplanned,
sure,
right? So as executed, every single one of those containers. I mean, you think of the hundreds of thousands of containers that sat behind that ship, waiting to get it out of the canal.
Yep.
every single one of the shipments of every single pallet of good, which is inside every single one of those containers, plan and execution are deviating dramatically from one another.
Mm-hmm.
Anyway, I just think that, that's kind of world that we deal in. But
so I want to get Amy's reaction to that. Is that the goal of prefab construction, is to kind of eliminate the occurrence of having to deal with situations like that? Is it?
No, I mean, look, at the end of the day, if you have hundreds of shipments, the beauty of having larger assemblies, I used to say this all the time. If I have to ship a data center to Brazil, and I have them shipping in 8 large pieces, and all of the critical components are within those 8 shipments, if you have an 80% chance of getting your stuff into Brazil on time, that means it's 0.8 times 0.8 times 0.8 times 0.8, 6 times, which doesn't give me an 80% chance of getting everything there on time. Now I have a better shot. When you have thousands of deliveries that have to make it there, the number exponentially gets lower and lower and lower. Because you need all those pieces to make the data center work. If you only need 6 large pieces, it's going to get there at some rate that is much better than if you have thousands of those pieces. So just larger assemblies have more certainty around them for that plain reason of just the numbers, right? I think my reaction to what you were talking about is that it's not like this hasn't been going on forever. The fact that we've had supply chain, as planned, as, built, as you would say, in that sense, or as executed. I think the combination of the pressures that are going on in the environment these days with supply chain, alongside the assumption-based design that, that many were okay deciding what those pieces and parts would be when there wasn't as much pressure on the supply chain. Those two, the combination of those two has created a lot of pressure, right? So I think it's just not one by itself. I think it's the two together that, listen, if at the end of the day, every single one of those components, whether they were large or small, were actually identified upfront in the design as real things instead of just geometry, we would have you would be relieving the supply chain of a lot of the pressure, because part of the data that you would want to understand is not just what is that component, but where is it coming from? What is some of the historical, as delivered information that you could understand, and you could actually pull on those levers to pick the right combination of pieces and parts if that data was available to you, that would relieve some of that pressure downstream. I think that's really my reaction to it.
It's almost like each thing in your plan is kind of this multi-dimensional object that reaches it down into the supply chain. And that has to be part of your plan in constructing that building, right? Or else you're not really considering it from all angles.
Well, if you think about it, the guys that actually have the most data about products and product components are actually the building product manufacturers. And they're so far downstream in the process of designing a building in the current state, for the most part. You think about it, you've got the architects doing assumption-based design, then you've got general contractors using static data of what they did the last time, which quite frankly, at this point, it's kind of, if you did it outside of the last 2-3 years, it's useless. And you've got static data there. You've got them passing that along to the specialty subcontractors who also are using static data, who then go through a distribution model of, 1 million different distributors that are going out to these building product manufacturers, that if they get 1 million RFPs, they don't even really combine them to understand that they're all going to the same job at some point. Right. So they're so far down the line that the guys that actually have the make data, the actual data, we need to find a way to get that content really digitized and upfront, so that it can be informing lots of this, including its supply chain availability and historical data on performance and delivery and things like that, you're able to have, you can use AI and machine learning to understand by, pulling some of those levers of AI.
But just even beyond or before we get to AI and the use of that, right now, so much of that is just unmeasured.
Absolutely.
And without measurement, you can't even build AI models.
Well, you heard in the SIGGRAPH keynote, he said graphics needs AI and AI needs graphics, right? So now, again, you don't want just graphics for coarse grained data, as you and I were earlier discussing, just to make pretty pictures in simulation. You want the actual data at some point to make the right choices, graphic with, the graphics that are associated with that actual skid, that rack, whatever, the electrical room. If you can have that and you can actually, then you've got real graphic interface to apply AI to that actually has like a data backbone associated with each. Like imagine if a skid had a data backbone of what's in it, where it comes from, its supply chain information, what its embodied carbon is, how much it costs and how it's actually as part of its data that's associated with that particular component. And again, I just love industrialized construction because the components are larger, right? They're larger assemblies instead of individual assemblies. And also the reason I like it is that's just the way people build these days. I mean, nobody does anything with a pump. They do pump skids, they build with pump skids these days.
Yeah. And also what are the environmental constraints that thing has as it's being moved? Everything has constraints. I don't care what it is. Would you meet them? I don't know, but they have constraints. When we oversee a lot of things coming into data centers that are being usually built within an integrator, right? Things are pre-built in that integrator, and then they're delivered to the data center. But all that does is just pushing the complexity. Still, the components still need to be brought into that integrator. All they're doing is pushing it off from the site. They're pre-building things and then they break it down. But some of these things that they break down, you're talking about big pieces, like the chiller subsystem, maybe 400 truckloads, 400 heavy haul truckloads to bring the entire thing in. And so what's weird about that from an owner perspective is from an ERP perspective, they're buying one thing. It's a roll up of a whole bunch of other little things. But that's a unit quantity of one that's spread across 400 trucks. And, so, and when is the 400th truck getting there? Where is it? What is the timeline of that thing? And, that goes for all major components, right? In that. But the integrator that's doing that has then their inbound supply chain of all of those components, who have their inbound supply chain of all of those components.
Correct.
And all of these things factor into this. You're right to say that, it's funny, we think of graphics needing AI and AI needing graphics. Really, the term graphic here is not the important element to me. It's the idea of it being a simulation of something. It's not just the rendering of things.
Correct.
It's about the simulation of that thing, right? We think of in games, the physics engine, right? How accurate is the physics engine in this game? How well is it modeled, the game? How high resolution are the models?
Just saying, like getting to a construction simulation engine.
Well, but that's exactly what they're talking about. Yeah,
right.
That's the digital twin.
But think about the difference. What you're saying the difference is that I think they've just scratched the surface of the opportunity with visualization. But again, like we're saying, like it's one thing to visualize and do simulation and emulation with coarse grained detail. The real win for that $50 trillion that he talked about penetrating is in the data associated with each of those particular components and where that data is going to live, how it's going to be associated. And by the way, that data is very different data if it's, data that's coming from distributors that are dealing in the mechanical electrical space, or if it's somebody from the structural space, or it's somebody who's dealing in Windows, who's a real manufacturer. There's a lot of different types of data out in the AEC world. And I think visualization, although it's amazing, and I think we should continue down that path, it's like the tip of the iceberg. And when you start getting into that content and where that content will be defined, whether that's open, USD in the Omniverse or other places, I think it's the name of the game at one day will be like, think about what you just said for that data center. You've got an integrator that's probably got, several large distributors. How much of their content is actually digitized at the moment so that you can see what content is there, not just what it is, but where it's coming from and, reaching into those ERP systems through one ERP system. You've got those guys, you've got, the actual process that they are doing on site. There's a tremendous amount of data there that's missing, but could be captured if there was a reason to capture it, if there was a way in which it could be used, which I think they were showing some great examples of how one day some of that could be used.
No, agreed. I think, and you're right, they're scratching the surface of it. The notion, though, of having a model, right, of describing the physical aspect of a thing, because here we're talking about things in the real world. We aren't talking about virtual things. We're talking about real things. But having that model live in Omniverse or OpenUXD is a descriptive of that thing, and the physics that things moves through, which could be moving it over ground, right? Simulate out the entire city. I mean, they can do that now, or county,
Absolutely.
right? And but at that actual component, first, in order to have all of that, what you need in that data set is identity. We do such a poor job with identity on things. I mean, little things like you have doors that go into buildings, right?
Right.
Doors don't have individual identity. You can't capture the data on these things unless you identify them and have persistent identity on those things.
Absolutely.
Once you do, then it gives you a place to at least reference information back to that identity. I think it was in Autodesk, they have the asset side of Autodesk. They were showing us at the data center show when we were there. They said is little used right now, but they have the ability of actually tracking every individual asset. And assets all the way down to individual things that go into the construction of something. Not even like the large construction of things like data centers, but buildings and anything else. The ability of having all those assets in something, and we'll say Autodesk, but it could be anything, but the ability, but you need to have it anchored in an identity, and that identity has to be easily accessible in order for somebody that's doing something with that thing to identify that something's happening with that thing.
Yep.
And it's like you need a data sync for that object, right?
Well, exactly. So if you think about like building connected, one of the things right before I actually left Autodesk was to get an industrialized construction, the products, the services, and the building types into building connected, which is their bidding system. Why was that so important for me? They need a name, right? So if you think about what Uniclass does or Uniformat in the specification systems of buildings, neither of those actually has a skid as one of the things. Neither of those has the way in which, as we were just talking about, a full electrical room or a bathroom pod or any of these things that have been now normal assemblies that we think of an systems integrator doing. They never had a name. And so it was very important for me to get them a name in a place so that, yes, as soon as somebody says, I can make that, okay, if we all know that that's, let's call it a pump skid, you have something that has a name that you can start associating data to.
Sure.
And part of the problem is in many of the, static libraries that many companies have, they haven't really standardized on the naming convention. They haven't had a great governance, if you will, on like how to create, better data and informed design with their component kits of parts. They've named like a door, like you just said, a million different things, even if it's the exact same door, whether it's a security door or an entrance door, like even if it's just the security door, they've named it a million different things. So I'm with you. I actually think you need to have, we've got to be able to look across, 50,000 components in somebody's library and make sense of it and harmonize that, if you will, in order to some specific way of talking about it so that you can associate some data to it and track that across programmatically and even like universally. Forget about even within one company, just universally what
exactly. And I think that, we actually have some IP we developed at CargoSense called QR sensor. But it was around this notion of what is a sensor, right? And I know this sounds tangential, but what it really is a sensor to us is a unique serial number, right? It's an identity of a thing. And the sensor has then data that flows into it. You can think of sensors like temperature sensors, right? Has an element that that measures the temperature and then stores that temperature in the sensor at a certain point in time. And that's what a sensor is. It is, these elements of measurement. It can measure light, pressure, humidity, all these different kinds of things. But really what a sensor is that unique identity.
Right.
To put a sensor on every object in the real world would be impossible for right now from a cost perspective.
And even if you could, it'd kind of be overkill.
Because all we really need on the thing is back to your thing, is a unique identity. So now imagine that sensor is virtual in the sense that it lives in a point in the cloud and it's independent of what it's on, right? So and what it is literally a QR code label, a sticker. Stick it on there. It's unique. So every door is that. But now I scan that and I go, this is a security door, to your point. Now, all the information about that security door and maybe that manufacturer of that particular door gets pushed into that sensor. So you now have a repository for literally that door. And then somebody moves the door on a truck with a bunch of other doors, right? That are but the fact that that door was moved, that actual load that it was moved through is stored in that sensor, that QR or virtual sensor. And it's just another bit of data. It's the BOL, right? The bill of lading for that shipment.
Right.
And maybe the trucking company that was used to transport it. And, and then where it's going to be installed and what position in that building is going to be installed in. All of that stuff, if you had that unique identity, and then you're right, what is it? The descriptive of it. You just need that common way of basically syncing all that data into either a common point, because everything with that identity, either everyone's going to have a reference to that identity in their system. That's one way. Or you just shove all of that stuff into something which could just hold a whole bunch of information that it doesn't need to actually analyze. It could be just a big binary thing, which represents maybe the three-dimensional design of that door. Fine. It could be the BOL. It could be a scan of the PDF of a BOL. All of that's just being stored there. Different people can use that data in different ways, pulling into maybe an open UXD model of that thing, right? And all of those things can be stored in that. But we have to all agree that in order to do all of that, you first have to identify things. You first have to get to the point of saying everything needs an identity. And then you need to be able to describe what those things are. And as you were talking about there, having a common hierarchy of those things, naming convention.
Because people want more than just bill of lading, right? So I think that's I used to describe it like this. If you ever watch the children's show, Dora the Explorer, she wears like a little magical backpack, right? Yeah. So she has this little magical backpack. And when she needs rope, she says, I need rope, and only rope pops out. In that data backbone, that data, that backpack of data around that particular object, whatever that is, let's say that door, in it can live all the information that you just talked about, but it's extensible. Yeah. So also that can live in that data packet is all the embodied carbon understanding of that, all of the information about, installing that door, all of the information about the inputs and outputs that you need to understand in the interfaces of that door with other components, right? So it's like that backpack is really that data packet, as you will, is extensible. But the issue is that, yes, if you're a big company right now, you can have your own library with your own data backbone with each of those kits of parts and component parts, as some of the data center guys have been leaders in. But what happens when you want to take a data center and move it to a different location, and you need to like change what is going to be available for you in that area? It's like, I think what's very interesting about the AEC space is that it's a 14 of that 50 that Jensen mentioned, 14 trillion of that is the AEC space. It is yet to be, put together, connected through e-commerce. Right. So think about that, a $14 trillion ecosystem that while you are trying to design a building, plan for a building, think about test fitting, there is no place you can actually click and go to find and search across where all that data might live one day, where you can say, I need a security door that is available and has the, delivery time of X in this place, needed by this time, that would actually be, applicable and works with these other 5 components. If you think generative, design, there's no place that exists right now, but for if you had your own private library of components. And quite frankly, they're not that sophisticated yet, because most people don't, they're not thinking about that's even possible, the data that they could be using it in that way. Some are, but very few. So I think that's what's really amazing to me. If you think about like what you just described is very specific to cargo sense. Sure. But if you were the environmental person on that job, there's a whole other information that you want out there. Like you said, it just lives out there. And what you want to do when you call for rope, whatever that rope happens to be, of what you want to compute about it, it exists. And you absolutely need data and AI attached to that physical component, hopefully represented graphically, that then you can, start designing some of these, not just the building itself, but where it's coming from, where it's going, how you're going to be,
Well,
using
and that
it.
data you're talking about there, which is like environmental data, right? Or carbon data, that information. And by the way, this goes all the way back up that supply chain, starting in, either felling trees or, ore and smelting.
Sure.
So you imagine that
Raw material.
these things all
Yeah.
say, okay, now this came from this smelter. It went from that smelter to this, and it goes through a supply chain. It's an evolution, right? Each of those loads have specific identities of that, from inbound ore going through a smelting process, coming out to then being turned into other things. Because people
Right.
need that. They need, when these situations happen where unfortunately people use things like child labor to do
Yeah.
really bad things, to be able to lower their costs of extracting things from the ground. Companies don't want to use that. So going back and trying to figure that out after the fact has been super hard. So many people have been burned in
It's
that.
almost impossible.
Well,
But think of what you just said, size of the prize. You're talking about stopping construction slavery, basically, at this point. There is construction slavery going on around this world. And we just don't have visibility into it. That doesn't make it okay, by the way. It's just there's not a lot of visibility into it. The other part is think about the size of the prize with sustainability. I mean, 40% of what's in our landfills, 30 to 40%, depending on the research you look at, is construction waste. Construction waste fills up, at least a third of our landfill is construction waste. By using assumption-based design, by designing with things that aren't real, that are just geometry-based, you're not creating an environment where you can actually use something that is easily standardized and made readily with the least amount of waste. So think about these things. I always use my example. I love Yeti, by the way. I love Yeti cups. So I always say, if tomorrow I found out on the news that this company, 40% of what they did to make this amazing cup landed in the landfill, which of course it doesn't for Yeti, but I would never buy another cup again. Sure. But somehow we are okay knowing, just because we don't happen to have visibility, that some of this is happening due to construction slavery. And much of this is happening with the result of, a lack of sustainable practices. Forget about now the big focus is on embodied and operational carbon, that we're doing this with, lack of understanding of carbon. Or as you said, I agree with you. I think water is even more important these days of operationally of what we need to start thinking about. We have almost no visibility to the impact, and we have such a need for infrastructure. Right. It's sort of the perfect storm where you need AI and machine learning and these interfaces to exist, because again, we're also in a place where we have lack of labor and skilled labor in these spaces where 40%, I think, of all people in our space are retiring in 2031. Right. And not me, unfortunately, but and at the same time, you have 200 million construction jobs that are necessary that no one can fill.
Right. Yeah.
So we only have a short window to start collecting that data from people that actually understand that, where it's inside of their heads. A lot of that domain expertise that we're talking about, you need data in order to train these models. Where's it coming from?
Right.
If the people,
it has to come from people,
right?
And the and it is where. Again, I when I was watching the Jensen's keynote from NVIDIA at SIGGRAPH, I just never appreciated how important the simulation side, the GPU side of simulation, and AI's use of that simulation could really drive the optimizations that we need. Exactly what you're describing, optimizing.
Agreed.
The economic impact of things, the sustainability impact of things, the construction of those things, the waste produced by those things, all of that could be optimized with AI virtually before you even think about starting a project.
Well, let's take it one step further. The beauty about what he was also talking about is that they're also not saying that they're going to build all that capacity, all that capability themselves. They're basically saying this exists for companies like CargoSense and every other company that's out there that wants to. I mean, think about what the beginning of the internet was like, right? Mm-hmm. How many companies actually capitalized? This is almost like that, but bigger, right? Like if you think about it, it's like, if you think about that, it's like, this is the opportunity for folks to actually start figuring out, because again, not one company, I always say, and there's no one ring to rule them all. Like you need a million little connective tissue like products and digital glue that holds all these processes together. There's unbelievable, unbounded opportunity now for companies like yours and others to capitalize on figuring out that little piece that you have the majority of the data and you understand. Like, and I think that's like the really exciting part about what he's saying, like that, you know, and what they're saying is that look at the business opportunity aside from sustainability, aside from like, look, the business opportunity alone should be mind-blowing.
Well, because you know, the internet was not about the physical world. The internet existed in the flowing of information. And yes, we had to get the information out of certain things. Yes, we didn't have the information about those things in it, but we developed it over time, you know, images and video and all these other, but they're all digital assets. Everything that's flowing over the internet is digital assets. The complexity here is we're dealing with real atoms. We're not dealing with bits. We're dealing with atoms. And when you're dealing with atoms, they comply to a completely different thing called physics and the economics of moving things, right? Which is physics. And there so little of software innovation thinks about that. There's just very few companies that are thinking about, you know, how can we, you know, they thought about how we can innovate around software, and thousands, tens of thousands, hundreds of thousands of companies do that. How do you innovate around things where you get into atoms? You know, one thing about CargoSense, what I love, and we're recruiting software engineers for our team, is you get to deal in the bringing together information and the real world. You're impacting the real world. And we're measuring the real world of something happening. And we're trying to build software that helps reduce what people need to do in order to make sure that thing in the real world, those processes are going according to plan. And that's what we're doing, right? That's our niche in this whole thing. But if you think of the amount of impact that AI, in order to impact the real world, needs to have a digital representation of that thing. It can't directly interact with the real world. However, if we can model that inside of the thing that the AI can then actually reason over, you can do that. And that's what he was talking about. And that's that marriage of, you know, an open UXD and the promise of that, all those companies that are working around that. It isn't about like, you know, the original thing about making movies. It's about the exchange of these these three-dimensional things and the things that those three-dimensional things are part of. You know, in Apple's new visualization headset, I was watching this and I'm like, wow, Apple was really prescient in building this headset at this time, because that headset is like, everyone's like, oh my God, it's so expensive. Who would spend $3,500 on a VR headset, right? And I sit there, and by the way,
the industrial applications for those kind of things are almost outweigh the consumer and personal use, right?
But okay, if I'm going to go buy a MacBook Pro right now, an M2 MacBook Pro, I'm going to spend $3,500 on it. And by the way, that headset is a MacBook Pro.
On your
it's
face,
just a MacBook Pro that you're wearing on your face that also has all the sensory data and the ability of overlaying that in augmented reality. This stuff it's going to be an exciting next 5 or 6 to 10 years. Like I think the bringing together of all of this capability, all the way into that stuff being able to be hosted, that computing power to be able to be hosted, like, you know, NVIDIA described, all of that is coming together right now. And you're right that it all factors around these big industries that have never, they make use of technology. It's not to say that they don't make use of technology, but the flowing of information, they're horrible at.
Yeah. So I want to hear from Amy on like, you know, right now and then kind of the immediate future. What's the state of industry adoption and interest in, like, you know, applying everything that we've been talking about here to their operation? Because we talked a lot about data centers, right? Because that's where we met you, was in the context of data centers and stuff like that. But what are some other industries that are kind of, you know, picking up the ball here and running with it? And what's the state of things 10 years from now?
I think first and foremost, it's funny, like being a prefabrication expert, I've never been a big fan of housing, by the way. Like, not that it's bad, not that we don't need housing, we do. So like, I want to make that very clear. I always talk about like, people are like, why isn't it starting with housing? And I was like, well, housing is very like shipping a lot of expensive air like that. And you know, it's been a very fragmented business for many, many years. The businesses that are able to push us forward. And so I had to make that, by the way, I have to make that caveat because everyone thinks I'm sort of like anti-housing.
No, that's going to be the title of the show is Amy Marks is against housing. So there we go.
I'm not. I want everyone to have a place to live, but I've realized that like,
No.
yeah, but the result of what we learned from the heavier industries that he talked about up there, like the manufacturing side of things, right? The pharma side of things, the data center side of things, the healthcare side of things, you know, where there's heavy mechanical, electrical, plumbing, where the cost per square meter or square foot is very high, right? Where there's heavy structure, fortified structure, and a heavy cost of MEP. That's where this really makes the most sense. And also I would say, you know, where there's serial owners. So where like you own 30 data centers, you own 50 manufacturing facilities. Sure. You know, like we talk a lot about disruption in our space, and like Clayton Christensen, who was my professor, talked about, you know, the innovator's dilemma, like you got to chip away at the bottom to like change over. That's how Uber beat out taxis and the mini mills get to the steel mills. I mean, that's true of like one small industry that like a technology could do that for you, but we're not, it takes like, I don't know, 17 industries to actually build a building, maybe more. And we need top down pressure. So you need the largest software companies like you just saw come together in OpenUSD. You need the largest customers, you know, all the couple of the ones that you've mentioned, like the biggest data center owners, the biggest pharmaceutical owners, the biggest manufacturers, you know, to come together. And they've got to, their expected experience has to be different than it's been. They have to demand certain things, and they can't just push risk down and expect that risk is going to go away, you know, or they can't just ignore the fact that maybe there is construction slavery, or that we're, you know, we have all this embodied, you know, operational and embodied carbon that they should be reducing for everybody. So I think I tend to, again, and by the way, I think the result of having those companies and those industries have adoption sooner allows for housing to come faster at that pace, because we're going to learn so much from things like data centers or semiconductor or, you know, any of these guys, that like housing becomes easy. It's like, it's almost like saying like, if you know how to build spaceships, then like bicycles are pretty easy. Asking bicycle guys to build spaceships is really, really hard. Right. Yeah. And I feel like let's start out by building spaceships with the guys that can afford spaceships, and it trickles down. I mean, and not to be funny, like even look at Elon Musk. I mean, he's looked at some prefabrication, including getting into the building product manufacturing in the prefab space. Why? Because, and in the HVAC side, because mechanical, electrical, plumbing on those types of applications with structure are like 60, I don't know, something like between like 55 and 75% of the cost of these buildings. Yeah. If you can't understand those in components, how they can be reused and extended in a programmatic way, and the data associated with that chiller, that skid, that electrical, we have to move in that direction, right? So I feel like, again, my love of industrialized construction, you can't just productize the physicality of that thing. You have to productize the workflows and the data associated with those physical things. Like you said, you need something to attach it to then start, you know, automating those processes and letting data be collected so that you can start using things like AI. So I think that's what I'm hoping for. And I'm hoping that some of these companies will start to see, you know, the benefit of that. So it trickles down to everybody.
Well, and it's to those owners' benefits to do this, because, you know, people like, you know, a Google or a Meta or even OpenAI or Azure, say Microsoft, you know, all of them are constrained by the number of data centers and the speed at which they can build those data centers. And all of this gets driven directly into how can you speed this process up? Yeah. And the way
insert any one of those heavy industries in the word data center. They make money by having hospital beds. Yep. They make money by having more cars out there. They make money by having more drugs hit the street. Like, they make money by having capacity. Fighting over $7 dissipative, you know, tile isn't going to make or break you at this point. Like, you know, it's like we need, and again, hire even more housing, whatever that, insert that word there. And you're correct, because it's sort of the innovator's deception, I've always called it. Like, you think it's going to change on its own by like a little ground up thing, but we know that's not true. Like it takes the biggest of the bigs to put pressure down because they have the most to
Correct.
gain, right? Like
Yeah, spend more and save more. Isn't that what Jensen was saying? Spend
spend
more
more
to
and
save
save
more.
more. That was my favorite part, actually, of the entire thing. Spend more
And
to save
everybody
more.
was kind of giggling, but he's right. And effectively, investment is a return, right?
Right.
And in this instance, this stuff that you're investing in, and whether NVIDIA isn't just NVIDIA, it is the ecosystem of this group that is working here are the ways in which the real world and the simulated world, and which is where we're going to have AI work against that. It's where they're creating that potential. But you're right, Amy, the actual owners, the people in those industries have to be the ones to push that into their process.
Right.
Because if they don't apply that technology, it's just potential. And
I think the scary part about what you're saying, oh, sorry, go ahead.
No, it's fine.
Please go ahead.
I'm done.
The scary part about what you're saying, right, is that who do owners hire? Who are the smartest owners hiring when they have to build facilities, though? Like, that's the issue. In some ways, I might wish that we run out of construction specialists quicker than even what it says on the projections. Because if you hire a guy out of XYZ general contractor these days, they're going to tell you it can only be done a particular way, right? Like in their very linear, very disconnected, getting paid on waste. That's where, again, I called it a cash for chaos ecosystem for a long time. People make money off the misinformation, the lack of information, the siloed linear process. If you're any one of those big companies that you mentioned and you've got to build, 10 data centers or, 20 hospitals, you don't hire a data scientist, manufacturing specialist. You hire a guy, right, or a woman right out of the space that has in their mind, their sort of tunnel vision that's all you can ever have is this. Right. And they don't really, not many can actually see outside of that and even if they can, they're sort of bound by like process entropy, like they make money the same exact way. Listen, it's not a secret. Architects make money by drawing things that will never be built. General contractors make money by bidding out things that will never be built or never be won. Subcontractors make money by, letting them know the things that can't be built or be, made like that. And so they've got to make something else that isn't quite the bespoke way that they have to make them now. So it's like, we have to have pressure. And who knows, maybe we do need, I will tell you this, all of this gets better when we've ever had crises. Like when there's crises in the world, like from, an innovation perspective, things are better. And so like, I can only hope that the way in which what the world is happening right now is that, and again, like when you run out of people that know how to do it the old way, it wouldn't be a bad thing to get some people that are like, what if we had to rethink this? And, what if it didn't work the way, that's very linear in this case? And what if people had to make money in a different way?
Well, and I think there that what we need to get it into is something out of the physical world, because the thing that limits people's experience in that space is it's so tied to physical real world experience. Right. And how many people get to go watch a data center being built, in that area in real time? They don't. We need to move some of that knowledge into the digital domain in a way in which it can actually be generalized and used. And there will be companies, hopefully, that are formed, not my next startup, but that could do that, right? Because the minute you actually build that and you build the example of virtually, let's just say, pulling all of that together and doing it in a non-physical way and being able to leverage embodied experience from people in that system, you're going to displace all of that expertise, or in this instance, supplement the missing expertise because those people are leaving.
Yes, that's how you have to say it. Yes.
So that's what we need. Startups, please do that.
Yes. And we need so many of them, right?
Yeah.
So again, like we talked about, it's a highly, fragmented, we have all these different industries. Like, and I think I always say, like, startups ask me sometimes like to sit on their advisory boards or to, be on their board. And I'll tell you the interesting part. sometimes when I'm like, all right, great, what do you do? And I'm on like the 8th slide of their presentation and I have no idea what this company does. Like, all I know is that they point out all the waste that's in our space, and that each one of them talks about the fact that we could cure, I always say, like, could cure cancer. But I'm like, are you like a mouth cancer guy, a hand cancer guy, a lung cancer guy? Like, could you get a little more specific on the cancer you're trying to solve here and like very quickly get to that point and like specialize in that particular? Because some of these are so deep and so special that, we need you, all the startups, to come out here and start specializing and solving, problems that, and again, can be connected on a platform with other data. Because that's also why I thought it was very interesting what they talked about at SIGGRAPH with OpenUSD and like Omniverse. Like, you need a platform that is agnostic, right? You need a platform that is agnostic to all the tools out there. And I think that was very interesting to me as well, that it can't live in one place. You've got to be able to have an open, platform where things can be made and built and consumed by like lots of different companies.
No, you need an ecosystem, right?
But you absolutely.
You need an ecosystem for these virtual things that are detailed enough, that are fine-grained enough, that then you can have companies that use the specialization around that.
Right.
And it's extensible, right? So one of the things they talked about, I think that what NVIDIA did for OpenUXD was deliver on this whole physics engine. And they allow you to have that physics engine be plugged into, that. And that they are all these folks are participating in, we'll call those generalized things, right? Generalized aspects of things. But now we can have people come in and do very domain specific things. The manufacturing of warehouses, the manufacturing of hospitals, the manufacturing of factories, right? Semiconductor factories versus pharmaceutical factories, right? They're going to have differences and you're going to have specializations, and that's fine. But they need a place to coexist, right?
They need foundational examples. Like they built some foundational tools and examples. I would use that word foundational, right? Like,
no, that's good.
You need to know what's possible and what you can build on top of. That's what I really saw, and I thought was so interesting that, they're not expecting you to like come up with nothing out of anything. Like, they're giving you some real foundational tools.
No, and I think
that was exciting.
No, it was totally exciting. And the foundation's there. And it's not just the foundation in the computation aspect of things like GPUs. It's the foundation in terms of visualization, like what Apple's doing, right? The foundation in texturing and modeling and all the things that the creative disciplines do. All of that can be brought together in a common ecosystem where we can participate in that. But there is this very specific knowledge of industrial construction, which needs to be also brought in to that, so that we can then reuse that. Because we're losing the people that know how to do it.
Absolutely. Yeah. And by the way, you made a very interesting point that I don't think we should let go, is like, you thought like, who's going to want to spend $3,500 on a headset? Like, it's the same question about the GPUs. I mean, like, they're more expensive than what people in our space are buying today. But look at everything that we just laid out as potential use cases. Like, you can't look at one without the other. And I think that's what's, think about how successful the companies that he was up there talking about are already, and like how successful NVIDIA is already just on them scratching the surface. Like, there is a real need. Like, if you explain that you could have these things that we just ideated, $3,500 for a headset, or like buying, I don't know, something else for 10 grand or 20 grand or whatever, or even upwards of whatever millions, it's so worth it. And I think we're going to have to get away from, at least in our space, that project-centric notion of like, well, the project has to pay for this thing or else I can't have it. It's like, if you think about what's spent on contingency, now think design contingency, construction, you're talking about percentages on percentages on percentages of what gets spent on just contingency alone. If you just remove that out of a job and bought a fraction of it with a fraction of that money, some of these tools, you wouldn't even need that contingency based on the data that you could be actually producing and using and understanding.
And
it would be like pennies. It's like lunch money.
And what I love about like the Apple example is the headset is augmented reality. It's not virtual reality. I mean, you could do that, right? But the fact is, it's bringing everything from the external environment to you and then augmenting that with these models. So imagine that skid showing up and you having to position it, and you can literally walk around that thing with your headset on. I mean,
Absolutely.
people, they showed examples of people with iPads doing that, right? They were like, waving the iPad around, and they could see what it's going to look like.
But there's lots of like stock photos with that sort of vignette, right?
Yeah,
like somebody walking around a warehouse with an iPad, and it's like astral projecting into the space, that kind of thing. Well, like here we are now, right? We're actually there.
But you can't do that and work with your hands at the same time.
Yeah.
And when you're dealing in construction, you've got to be doing other things with your hands. You can't be holding an iPad all the time and just looking. And it's not about looking, it's about learning. And it's about where does information that, I'm waiting for this thing, we're going to be constructing this thing, these are the things we're going to be doing today, we're going to be putting these doors, and literally be able to look around and see it. And then then information coming up in that same thing that says, this inbound truck is delayed, we're not going to be able to do this today.
Right. Because it's not only looking at data, it's collecting data also. Remember, right? Like collecting, think of all that LiDAR data that like literally gets collected on a daily basis. And what are we doing with that data? And what could it be connected? Nothing is the right answer, to be honest. Like, I mean, really, we're doing nothing with it. And I think of all things, it's kind of like a perfect storm. We have all this data that people are spending a lot of money to collect. I mean, and it's just going in the trash. Like, it's not being reutilized. It's not being repurposed to have better understanding of these components and pieces and parts, of its delivery time, of its performance, of its, capabilities, of its functionality with other things. I mean, so I think it's just, for me, I was super excited about the announcement with the groups that are participating, all of the partners. And I was super excited about the way in which, they're positioning like OpenUSD and Omniverse, because I think it's necessary for this. I think I haven't, but for, I was really inspired coming out of there and seeing all the great things that all the companies that are partnering with them are doing. And I think it was just a really inspiring moment. Like, look, I always say, like, I'm in this game because I want to see this get solved. Right. And so, like, I always say I'm a mom first. And so it maybe sounds a little like kind of corny, but like, what kind of world are we living with if I know that I could help waste avoidance of 30 to 40% of what's in our landfills? Like, I watch those videos of these guys like pulling plastic out of the ocean. If I had the personal capability of collecting plastic like that and disposing of it, recycling it out of our oceans, you couldn't stop me from doing that. Like, that's how I really felt about SIGGRAPH, coming out of SIGGRAPH, that I felt even more hopeful that, the world is changing and ready for this. Because again, like, it's funny, like in 2007, I did a project where we did 4D simulation about the crane on a job site, right? We did 4D simulation on 5 buildings. We realized on one of them, we were going to hit the building with the crane. So we had to get a crane extension, a boom extension. Now that was in 2007. I know of very few projects that are using crane simulation with component parts to this day. Yeah. Right now, by the way, it saved us from hitting the building with the crane. Now, can you do that today? Yes, you can do all. By the way, everything that you and I talked about is possible with the technology today. It's how you decide you want to interact and behave or create return on investment with those, that technology, right? Like, and that's the answer, really, right? Like, it's not that this can't be done. It's that, are you willing to let go of the $100 bill to grab onto the $1,000 bill and change the way in which you do business? And that doesn't come without disruption to your own business, right? I think that's the part, because we're so always on the margin edge with like GCs in particular. It's like, when you're working off a 2.5-3% margin, like, are you really going to stop everything you're doing or figure out a way to do things differently? And some are not. But, if you ask me where it's going to come from, it's going to have to come from the technology companies that are out there, the smaller ones, integrating with the big owners that are requiring this right now. And then the other guys will just have to get dragged along, whether they want to exist in that future state or not, whether you're, again, architects and engineers and general contractors. And if you don't have the make information or the technology to be one of the integrators of this information or the integrators of the process that makes this better, that you've been able to identify, I don't know what purpose you're going to serve 5 years from now, and that's what you have to start thinking about from a resilience of your, resiliency.
We can't expect those that are physically building the buildings to be the ones that will take the lead on the use of, or the creation and use of information, right?
Exactly.
So we have to give them the information so that they can do what they need to physically do. The owners are the ones.
Well,
right.
Yes.
Yeah. I was going to say the owners are the ones
for sure
that have the biggest to lose and the most to gain.
Absolutely.
And then everybody else gets pulled with that. And there aren't many of those, and there don't need to be many of them, because once that happens, what'll happen is those that are building things, those GCs, are going to be like, hey, when we're working over here, we have all of this, and it allows us to be this way.
Right.
And that will create a network effect of saying we should use that over here, or we're going to be more comfortable using that in a different area. But I think that the challenge of this stuff is, okay, let's go get an R&D budget for our owners of building data centers. Let's get an R&D budget around what we could do with all of this technology today. And I'm not saying they're not doing it. I'm just saying that's what you need to do. Now, that might be one thing for data centers because they're dealing with, those companies are typically, technology companies. Now let's talk about hospitals. Very different kind of space. Or general warehouses.
Absolutely.
Very different kind of space.
Or townhomes.
Well, we aren't talking about homes because homes we don't like homes.
We love homes. We want everyone to live in a home.
We do want everyone to live in a home. But what will happen is homes, it's like it was funny. You were talking about this needs to happen on the major construction side before it gets down into the personal construction side of the home. This is no different than saying we started with computers and mainframes. And then we eventually got PCs, and eventually we got phones in our hands that are supercomputers, right? So, what'll happen is these things that affect how we construct the biggest things will then come down and affect how we construct the smallest things.
100% a great example. And then those use cases, look, I fully envision one day I'm going to walk into, my vacation condo that is owned by one of the platform services that comes with all the smart features inside of that they know exactly when I walk in the building, what my temperature is, how I like my coffee, what the air conditioning needs to be, what my heart rate is based on how I want that space to be. I mean, we have that now in some of the biggest commercial buildings. People are trying to crack that code, right? But I think all of that happens as a result of them trying to do it at a giant headquarters somewhere else, right? And then it gets democratized into that I can have that same technology in my home, just like I have it in my hand, in my phone right now. I think the issue has become in the industrialized construction space, at least for me, if you look at all the governments that have tried to do something in it, whether that's the UK government or, any other government, that's the one that comes top of mind at the moment. They kind of go to the housing guys that are doing the housing projects and expect them to somehow crack this code. Right. And I'm like, again, that's sort of my roller skate, spaceship model. Like we'd be much better at these government entities going to the manufacturers in the space and trying to beef up the data and the connected tissue around technology and manufacturing than you are in the housing world, because it's almost like a waste. It's a waste of your money because it would come faster if you focused on the things that the result would be that we'd get better housing because we've learned all this stuff from semiconductors and hospitals. And
imagine if in order to manufacture and sell here, you have to provide certain data about your product. And that data has to be high dimensional, 3-dimensional models. It has to be, the carbon footprint of your product. All of those things governments can mandate, and it's not creating an onerous thing. If you're going to manufacture a thing, you're already investing a huge amount of money in the manufacturing of that thing.
Absolutely.
And so the ability of saying, oh, and I also have to provide this in this detailed way, governments could absolutely be something that helps. And the minute like the US does it or the EU does it, it'd probably be the EU.
Right.
because they don't
Or
mind it.
Singapore. My money's on Singapore.
Or
maybe.
Singapore, right? Wherever it is, somebody comes along and does that. It's not like those major construction companies aren't building in Singapore and building in Europe and building, especially on the industrial side, everywhere else
Absolutely.
in the world. So if a country does that and they have to do that and things conform to that thing, it will spread. Governments can have probably the biggest impact there is
Agreed.
demanding a consistent data representation of those things.
Well, think about it. Think about what you just said. I mean, I've worked for the Singapore government for several years on their productivity initiative, right? So what's so interesting about what you're saying is currently governments, let's just talk about what they spend their money on. If you're a government and you spend $100 to construct something today, and it's the taxpayers' money or the constituents' money, $100, you're talking about 41% of that $100 is transactional waste.
Right.
Right then, right off the top, you've spent 41% of that $100 in transactional waste. After that, of the materials that actually get bought with the money you have left over, 30 to 40% of that material is ending up in the garbage. If you are a government entity at this point, what have you actually done or what could you do with the money that you didn't waste? You could have 10 more hospitals or 10 more housing complexes or whatever it is that you're buying. But currently what we've only had around the world is BIM standards, right? So like the only thing that people really focus on is BIM standards, and that's not data standards. Like we're talking about when you and I are talking about the Omniverse and data coming from all over the place and like extensible data. There's no such thing as data standards that have been defined by any one of these entities that exist out there. And actually, or a data schema even that other people could define the standards. So like, I'd almost rather that. Like everyone used to ask me all the time, is so-and-so the company you work for going to make data standards? And I'm like, why? I'm like, I don't think they should tell you how to make a pump skid, but like, look, if I'm Amazon and I want to sell on Amazon, I have to meet a certain data schema, whether I'm a manufacturer, reseller, or a distributor. If I want to sell on Amazon, they're not going to tell me how to make shoes. They're going to tell me how they want me to represent my shoes that I want to sell or whatever it is that I happen to like shoes, but whatever it is that I'm selling. And I think no one's really done that, right? They either want to own or they want you to own how we're going to make shoes. We don't need that. We just need a place for the data to be stored, and it needs to meet a data schema so that you can search across it, consume it, and compute it, regardless if it's Tekla data or Autodesk data or, Hexagon data, whatever. And that way you could actually start understanding as a government entity, we are going to require these data standards and these BIM standards for our project because why? We don't want to have wasteful processes. Right. You would, or you got to design with these kits of parts that are very specific, at least the expensive things, right? Like that's what, if you think about like what Volkswagen did actually at one point, like think about what they did. Besides having an amazing supply chain, platform that they've built out actually with one of their partners. I mean, they literally have this MQB product, which is the very expensive engine components. You can't touch those, right? Like, and they said, like, we're going to build 40 different chassis or so off this MQB, but this is very specific. Don't touch this. Don't make this any different than what we've prescribed. And it's where 60 to 70% of the cost is in this like little engine block. The rest of it, you can make longer, shorter, taller. That's why they have minivans and sports cars, but they all have that very, very specified and specific, core. And by the way, an engine block is no different than like the wet walls in a building or the medical head walls or whatever it is that you're going to say, right? So I think it's just we have to recognize that the way these business models were set up in the past to make money off the lack of information, it's not going to fly anymore. Especially if the big governments and the big end users and the big technology companies create a path forward for that not to be, right? And that's what made me excited about SIGGRAPH.
And it can be that the owners in those, which the government is one, right? If they're funding that. But, the owners can influence the requirement of this thing. It's one thing to say, people provide dimensional size, weight, right? They have basic things that they have to provide as part of any manufactured thing. They do now. But it's not onerous to lay upon them the need to provide a detailed three-dimensional model of that thing at whatever level that is, so that it can be used in the compositing of that thing to other things. Because every manufacturer has one of those. I guarantee they do already. It's going to be in whatever system they have. And maybe it's, AutoCAD, or they design it in whatever they design it in. But if they could have a common thing that they have to publish that in, and then that SKU from that company is represented by this model, and governments mandate that those models have to exist so that those things can be composited or sold or inventoried or stocked, or all the different things of what is required. And by the way, packaging around those things, same deal. I want the packaging to be modeled so that we know exactly what that is, because that allows people, like, all the way down to the retail side, but to optimize the storage and movement of those things.
Absolutely.
None of that exists.
Mm-hmm.
No.
Or the packaging to be reduced.
Oh,
like, think about how much extra packaging we get every single day. So, I mean, if you think about it, what's so interesting about what you're saying is that I think, and believe me, there are plenty of people that are like, yeah, but we have this like plugin over here and that plugin over here. The difference that what we're describing, right, is that what if you wanted to search across all those plugins? Right. Like, what if, and that's, I think, the promise of something like an Omniverse, right? Like, and again, how you're searching and what tools you're using, because you want to search and do something with it, whether it's like, I want to understand I want to put it this way. What if one day I want to design a building that has the fastest supply chain routes in order for me, that's more important to me right now, the fastest available supply chain routes for the materials that I need, than is sustainability right now. Let's say I had to build a pharmaceutical facility right now because I needed, the quickest amount of time to put together a fast drug. Because we're in a pandemic, not like we've ever been there before. Like, because we're in a pandemic right now, we don't have the data available for anybody to even know what that could look like. Like, our data in the AEC space, it doesn't even like comply. It's like the redheaded stepchild of data right now. When you think about what risk data looks like and banking data looks like and other people's data looks like, because again, we have been slow to digitize. So our data is like, obviously is not as robust, but like, think about the applications of like, look, the digital divide happened with the pandemic, not just that we needed pharmaceuticals. Like, we had kids in this country, in the United States, that couldn't go to school because they couldn't get on the internet, right? Like, imagine if you had to understand, and again, if you had all that data with that, with all the information, you could pull different levers. Maybe it's okay being like a little bit longer if you had the most sustainable practices. Maybe you can weight those and say, I'd like to be this sustainable, this fast, with these cost measurements. And by the way, there's also, it was funny, recently, last year at AU, I sat through a neurologist that was talking about digital twins in neurology. I think I was probably the most excited person in the room. And it was a bunch of AEC folks, and they were talking about, had people in theaters and they could measure, I think it was the carbon dioxide that they were breathing out when they were stressed in the theater, because they were looking at rock climbers, right? So think about what we just said about the extensible backpack. Everybody was like listening to that, and they were like, okay, that's kind of interesting. Or they could look at eye movements and collect a lot of data about the person and know things like your future health and how you're feeling today. And I would say like most of the people in the AEC space walked out and they're like, oh, that's kind of interesting. I don't know how I use it today. Interestingly enough, I walked out of there, and a friend of mine who was building 300 pet stores had recently talked to me about the fact that when he talks to architects, he's like, how do I know and make sure that the combination of what we're designing in these pet stores makes the owner and the pet feel safe and happy so that they actually buy more things? And I was like, I actually don't know the answer to that. But after I walked out of there, I was like, what if there were sensors sucking in the air and they could understand in each aisle whether or not these people were stressed, and like if they were stressed because their dog got like stressed? I mean, like, these are real answers to real problems that we just have never really thought about could be possible, right? I think we have to start thinking in our daily life, we would think that's possible. But in the world of AEC and what we're all talking about, we have to sort of like break the idea that none of this is possible, and it's all possible right now. I mean, when I told my friend that, I was like, imagine if you actually had sensors for carbon dioxide in each of the aisles collecting. I mean, and again, that's not very expensive, right? Like you're talking about something that's very relatively inexpensive. Now, if each one of the combinations of the aisle structures actually had data associated with, we could say, when you put these things together, this combination of end caps and the way in which you set the aisle together is the one that the people felt happiest in it. And by the way, if you actually cross-reference that with those people with what they bought, because you track them as they were walking through the store, like Amazon does now when I buy stuff there, like you could actually understand if you're really right, if they feel safer, do they actually buy more things? And you can have a correlation to that maybe or maybe not, but at least you could start testing out some of these things. And then you could start understanding to create the right aisle spacing and aisle components to actually, and this is where, to make more money, right? Because like, and have happier customers, like those two things. And I think we sort of forget that part. All the time.
And this gets back down into measurement, right? Measurement is critical. And a lot of times, but you need a place for that measurement and what to do with that measurement. And, you know, but if we have a common way in which we can share that measurement, then these different applications of that measurement are possible. It's not possible if we don't measure. It's not possible if we don't model. But if we model and we measure, you could ask Dora's backpack for anything you want, right?
Absolutely.
That neurologist, or maybe a whole neurologic program, my daughter's a neuroscience major, could ask for that data to do research on, right?
Of course.
But you can't ask for that right now. What's the cost of research to be able to build something like that, to build that data set? Because there's no way for us to tag that data. We have this data for this reason, and we're using it, by the way, for optimizing the amount of money we make in our stores. Awesome. But now researchers could use that very same data to be able to do things and learn things that can actually drive better optimization or better experiences for people. But we need that common language. And
by the way, that's why NVIDIA has a great healthcare program, by the way. I don't know, they have a really blossoming healthcare division. And I think just for some of the things you've just said, how important it is that they're looking across these different places, right? And that all these companies start to think about, because really what you just said is there's a convergence, right? Like it's not just about construction. It's not just about healthcare construction. It's about how these things interact with the healing process, with the experience of these people, with the money they spend. I think there's a real convergence happening that we've been unable to really get our hands around and show importance about it. And again, like you're never going to get a GC, I would say, the majority of them, to see what you and I just talked about. Even if they could see it, they would say it's not their responsibility, right? Like they would be like, well, if the owner wanted that, we would help facilitate it. And I think the big owners and the big, the big authorities having jurisdiction, the big governments, it's sort of like, so again, to Clayton Christensen, he thought bottom up. It's actually the innovator's deception. It's like, we need top down, by the way, with a bunch of ecosystem players filling in the gaps of these big companies, right? And that's what's so important about what's going on, is finally I'm starting to see some light in that somebody can facilitate from both directions, multi directions, some of the things that are necessary for this to be possible.
Yeah, because you need innovation. And you need the power to apply that innovation to disrupt things. Yep. You need both of those things.
Agreed.
Yep.
Agreed.
So Amy, to round this episode out, because we kind of at the top we kind of just like cannonballed straight into the deep end, and so I want to resurface, and I want to hear a little bit more about how one becomes the queen of prefab. A little bit about your story and your path and how you got to where you are.
Sure. I think it's so funny. People expect me to talk about like panels and bathroom pods or something on these, shows. And that's a little bit of my roots, like I used to own factories and I owned construction companies. But when I was in Asia for a big conference one day and they were paying me to come out and speak, I used to do a lot on the paid speaking circuit. And even last year, I think I did 40 to 50 keynotes. But like I went out to speak at a conference and the gentleman said, "Where's your boss?" And I was like, "What do you mean?" And he was like, "Where's the CEO we hired?" And I was like, I'm actually the CEO.
Oh, you are.
So I used to sign my name. Yeah, A. Marks, not Amy Marks. And he was like, "Oh, what?" And then he walked out on stage, like literally right before we were walking on stage. He thought I was the assistant to the CEO, cool. I think. And I know. And he was like, he introduced me as the queen of prefab, I think, to make it look like they had a cooler speaker. And I sort of laughed. And this is a true story, not because the Barbie movie's out. I actually made a joke, like something like, "Wow, I wish that Barbie wasn't taken." But, like they gave me this nickname and my friends and I started hashtagging it almost as a joke, so that like we turned this embarrassment thing into something that was, I could own and it was like, I'm not going to let them embarrass me. I'm going to let's own it. Right. So we started hashtagging it. I mean, I think 9 million views on YouTube later for a couple little videos we've made with the name on it. It's just, I feel it's funny. Most people, I won't make a gender bias, but usually most men ask me like, "Why do you call yourself that?" And I was like, I actually didn't call myself that, actually. I picked the name up and I've owned it now because somebody else called me
Right.
that. And I really I like it, but I will say it does me a little bit of a disservice in the sense that like I'm really more about platforms and convergence and sustainability as well as industrialized construction, like the future of making things. But the Queen of Prefab just stuck. And so like I keep with it, but like, you know, and of course I love industrialized construction, but I like to say like there's so much more to me and to what I hope for in the future state besides industrialized construction. So that's how the name came to me.
Yeah. No, it was awesome. Thank you so much
Yeah.
for coming on today.
Great guest. Appreciate you. This has been great.
Yeah.
Crowd loves it.
Thanks, guys.
You know, kind of ironically, last Wednesday, I was at NVIDIA's headquarters for another
Oh, wow.
reason. But
Full circle.
yes, so I was in that building.
Interesting.
It's a beautiful building. Absolutely stunning. What's great is they have a nice big wall of plants. Like, you know, it's like 50, the
green
green
wall?
wall, which of course back to Singapore is all over the place. And it
Yeah.
reminded us of Singapore. I'm like, oh, this looks like
Inside and
Yes.
out, right? Like in Singapore, it's inside and outside that green.
it's
like,
awesome. I love the
interface.
merging together of that in
Me
Singapore.
too.
Yeah. Well,
right.
Amy, if,
Hey,
if
Rich.
people want to learn more about yourself, where can they find you?
Yes. Well, I have a website, queenofprefab.com, and you go
Yeah.
figure. And on any social media, it's Queen of Prefab. But for I think on LinkedIn, you can just Google me and it'll take you to my LinkedIn, Amy Marks.
All right.
So yeah.
Great. Well, Amy, I really appreciate you coming on again, and this has been a great conversation. I really
Yeah,
enjoyed
awesome.
it, and thanks for your time. Hope to have you on again sometime soon.
Anytime.
All right.
Thanks for having me,
All
you
right.
guys.
All right.
Take
Thanks,
care.
Amy.